exciting. All right, so on the chapter 1 test, let me find my key here. All right, everything's good on the first page. When you get to the second page, number 11. So these are 3 different functions, and then I've asked you to basically perform different values with the functions, just like you did in your homework. But when you get to E and F, those are supposed to be compositions. So I know when we did our, the notation should actually be H open dot G. That looks like hog now. Of 7. Or I probably should have just written it like this, but the book didn't, so I didn't. So it's H of G of 7. Does that make sense? So E and F are compositions. So it's a closed dot, and it should be an open dot on E and F. And then the other one this is just a tiny thing. I'm sure you guys can figure it out. But here in 13, it says G of X minus 1 squared. This should just be an equal sign. So if you get to that and you're like, whoa, is she trying to make something crazy? No, I just hit the wrong button instead of the equal sign. So hopefully that will clear some things up. Everything else looks good. I took the test as well, so we're all good. Well, I made the test, but then I went back and took the test just to double check that everything worked out all right. So any questions about that? Sound good? Make sense? Everybody's quiet, so that's good. Did I wake you guys all up this morning? All right. I did wake you up, huh? Or yes, everything's good. One of those two. Okay, so I did want to, we technically didn't finish chapter 1 all the way. Oh, Aiden, that sounds like some really light reading that you were doing. That would put me to sleep if I was up late reading that. Yeah, I was gonna say Aiden, yeah. I probably would have went to bed. I would have just kind of passed out. We didn't quite finish up 1.6, so I did want to do the last few examples that we didn't get to in 1.6, and then I want to do just a slight little bit of chapter 2, only because we're going to talk about the quadratic function, which I'm sure you guys did a ton of in Algebra 2, and we can play with the graph, and that's much easier to do online. So you're not assigned to do 2.1. I mean, you can start it if you have extra free time after your chapter 1 and your test and all that. But I just thought it would be easier to do a few of those things while we're online and we can play around with the graph. So that's what we're going to do today, unless anybody has any questions before I get started. And if you have any questions that you come up while I'm talking, just type them to me and we'll do that. All right. The never-ending picture. All right, so let's go back to the notes. The last little bit of 1.6. All right, so if you'll remember, 1.6 is all about finding the inverse of a function, right? So and I don't even remember, was it 1.4, 1.3? One of those sections, we talked about what a function was, right? And we had these criteria for what a function is. And then we talked about different ways that we can transform our function by adding it to another function or composing it with another function. And then we kind of accumulated all that information into 1.6, where we learned about the inverse of a function. So not only do you have a function, you have the inverse of a function, and you have to find out if that's an inverse, if that's valid as well. Okay, so one of the things that we talked about is that we talked about how to find the inverse of a function, and we talked about how to determine if a function has an inverse or not. Okay, so so what we talked about, just to kind of review, is that in order for a function to have an inverse, it not only has to, the function to be a function has to pass the vertical line test, it also has to pass something called the horizontal line test. Okay, so let me pull this over here to our notes. I think we talked about the horizontal line test, right? Yep, okay. All right, just making sure. So, did we do 30 and 32? Yeah, there you go, Aiden. Aiden is demonstrating that number 30, that is a function, right? That's a quadratic function. So we're good for that. But it is not that does not have an inverse because it does not pass the horizontal line test, right? So what about number 32? Is that, I know, echo again. Usually echo happens if if anybody happens to be using their speakers on their computer, because then whatever microphone you're using picks me back up again. Or it could just be technology, you know. All right, so what about 32? Is that one, is that a function? Yes, right? Does that function have an inverse? Yes, it does. Yep, it does, because it passes, awesome. It passes the horizontal line test. So it says it right here. In order for a function to have an inverse, it has to be 1 to 1. So you know how we do have some functions, like this one, for example, that share two values of the range? Well, when you have that case where they share two values of the range, then they're not 1 to 1 matched, the domain and range. So then they won't have a function anymore. Wah, wah, wah. So we didn't do these last few problems down here, but I think probably even if you wanted to try them, you probably could. We could probably do it by looking at some of them. It says in exercises 35 through 46, use a graphing utility to graph the function, and then use the horizontal line test to determine whether the function is 1 to 1 and so has an inverse function exists. That's weird. That's weird grammar-wise, right? I'm not great at that. To determine whether the function is 1 to 1 and so has an inverse function exists. I don't know. Math has some weird language, but that seems a little off to me. All right, so all you're going to do with these is you're going to graph them, and you're going to see, does it pass the horizontal line test? Now, you can kind of test yourself before you even start it to see if you really have it, right? What about number 36 here? Do you think, just based off of the fact that we've got this x plus 2 squared, do you think that this is going to have an inverse function? Aiden feels firmly no. I'm with you, Aiden. Kind of feel like no, right? So yep, Jennifer agrees. All right, so let's just put it into our graphing tool. Thankfully, these are all solved for us, so they're nice and easy to put in there. And I have my paper here. All right, there we go. So this x plus 2 squared, this just really indicates that we're dealing with a parabola. That's our parent function, right? Or a quadratic function, which is the graph is a parabola, is what I should say. And so because of that, we do not pass the horizontal line test, so so that will not work. Well, that will not have an inverse function. It is a function. It does not have an inverse. Okay. Let's look at number 38. So what do you think, looking at number 38, just looking at it? G of x equals 4 minus x over 6x squared. Yes, no. Put it in. Let's go ahead and put it in Desmos and see what we get, okay? Or your graphing calculator. Oh, I made a really crazy graph because I have a whole bunch combined in there. There we go. All right. So we have an x divided by an x squared, and we get this cool graph. So what do you think? Is it a function? Yeah. Yes, it's a function, right? And then Aiden, you already answered in the next question. Does it have a inverse? Nope. It does not. All right. So pretty easy. Thankful. I'm always, whenever I get to problems like this, I'm thankful that I have a graphing tool. Can you imagine doing pre-calculus or algebra 2 without a graphing tool? Like when you had to use like a slide rule and like plot everything out. I cannot. Yes, you mean right? Yeah. Plot all of our points out. No, thank you. All right. And then the other problems, there was 2 last little problems there that I think you have in your homework. Let me double check your homework here. I just want to make sure we cover over everything. Okay. So in exercises 47 through 48, determine algebraically whether the function is one-to-one. Verify your answer graphically. So if it was me, I would prefer to verify it graphically first and then do the algebra. But basically when someone asks you to do it, to verify it algebraically, they're asking you to find the inverse algebraically. So this is just a good review of how to do that. Yeah, write with a pencil, Aiden, I know. Oh, that's not what I meant to do. It's like, no, I don't want to do this problem. Let's just copy this little. Well, let's just do a whole new page. So let's do number 50. F of x equals 3x plus 5. Oh, goodness. Okay. So what do you think just based off of the equation? F of x. Actually, let's do 47 from your homework. So f of x equals x to the 4th power. This is number 47 from your homework. It's same kind of deal. Sorry, when I draw like that. All right, so let's determine algebraically first if this has an inverse, and then we'll check with the graph. And you probably already have a hunch whether or not it has an inverse function or not. But let's just double check. So this is a good review of how to find the inverse function. All right, so there's like a little box on your notes up at the top. First, it says use the horizontal line test, but they want us to do algebra first, so we'll do that. So what we're going to do is we're going to plug in y for f of x, okay? And then in order to find the inverse, we're going to switch our x and our y in the equation. So y becomes x, and x becomes y. And then we have to solve for y. So in order to solve for y, I'm going to take the 4th root of both sides of my equation. Okay. And don't forget my plus or minus. I always forget that, right? And you're left over with y equals plus or minus the 4th root of x. Okay. So what do we know about when we have this plus or minus a root? When we have plus or minus, that means that we're going to have most likely a graph that looks something like this, right? We have the root plus or minus. And this will not pass our vertical line test. So I'm pretty sure this is not a function. Oh, wait, I forgot a step. Guys, let me forget a step. Because this isn't a function, this is an equation. So it technically should be the inverse function of x, right? Equals plus or minus the fourth root of x. So let's flip over to our graphing tool and see what these guys look like now that we did this algebraically. Okay, so our original function was f of x equals kind of our flattened out parabola. So just purely based on graphing the function, does it have an inverse? No, excuse me. No, right? Because it doesn't pass the horizontal line test. But we went ahead and found the inverse function, so we might as well graph it. I've never actually tried to write inverse function in here. Yeah, that doesn't work. Okay, that doesn't work. We'll just type in the inverse function that we found, right? I don't know if you can do plus or minus. I know I can do fourth root, though. So we might have to just type each of them in. The fourth root of x. So it would be, we would have an inverse if we didn't have this plus or minus thing, right? If it was only over a specific domain. But unfortunately, we have a positive and negative value we have to deal with. So this is not a function. Exciting stuff, right? You guys feel prepared? Any questions? It's very quiet in the morning. Yeah, I'm gonna get into more exciting stuff. Chapter 2 is all quadratics. Not better, not more exciting. And polynomials. And complex numbers. Actually, complex numbers are easy. And functions and asymptotes. Oh my. That's all right. We can still have fun while we're doing it, right? Sure. Okay. Let me give you a short introduction to chapter 2, only because we can play with Desmos, and I think it's easier than watching me graph on the whiteboard. So, and I'm pretty sure for everybody this is going to be a review. I'm sure whatever Algebra 2 curriculum that you used had a whole chapter or chapters about quadratic functions. All right. So if you recall, and I haven't handed out the notes yet. I have them for you guys on Monday. So don't worry about, you'll have this copy of the notes. But let's talk about quadratic functions. Did anybody memorize the quadratic formula? Yeah. All right. So the definition of a quadratic formula, the definition of a quadratic function, we're not to quadratic formula yet, is that we have a function and we have some constant a times x squared, right? Plus a different constant b times x plus just a constant c, okay? And a cannot equal 0. Why can a not equal 0? Because if a equaled 0, then this would cross this off and we would just have a linear function. So that doesn't work out for us. So a quadratic function has to have some value, even if it's just 1, we have to have an x, basically an x squared term to have a quadratic function, right? The basic graph, and we've talked about this a lot already. What's the basic graph of a quadratic function? because sometimes I just call it this. A parabola, that's right, Aiden. A parabola is the basic shape of quadratic functions. Okay, there's a couple of points that are points that are interesting about quadratic functions. If you like math, they're interesting, I guess. This point right here, that is the minimum value for our function, is called the vertex, right? Sometimes we will have a parabola. For example, if our function was f of x equals negative x squared, this parabola actually opens down. So we would say that the parabola over here opens up. This parabola opens down. It's pretty obvious by looking at it. So the vertex right here is actually the maximum value. My pen will work right. The maximum value. And this is the minimum value. Is this all a review for you guys? It's good to review it anyway, right? Okay, the other kind of interesting thing that math people get excited about is that our parabolas, our graphs of our quadratic equations, are symmetrical. Okay? So, and they're symmetrical about the axis of symmetry, which goes through the vertex. Yay, that's exciting, right? The last thing that I want to mention is that there is a standard form for the quadratic equation, which we'll talk about on Monday. But the vertex in the standard form is at point HK. The only reason I can remember which one goes first is, thank goodness they put them in alphabetical order. H-I-J-K. Okay. So we'll talk about the formula for that, but that's kind of the standard nomenclature. So the only other thing that I wanted to do was to actually pull out our graphing tools. So Desmos, your calculator, and we're going to take our basic parabola and we're going to do some different things to it and see what happens. Okay, so this is just kind of like getting a feel for how can we transform our basic quadratic equation. What happens to the parabola? Okay. And actually, if I remember right, oh, that's not what I want to do. So this is another option that you can do in Desmos, is add these things called sliders. Okay, so the slider actually will just change your value without you having to replug in the equation. So if you really want to play with your parabola, you can just slide it around. All right, so this, for example, would be the graph of f of x equals x squared, kind of our standard parabola, right? And so then we can see what happens if I change my number that's out front of my x squared. If I make the number larger, right, my parabola opens up a lot quicker, right? What happens if I make my number smaller? Or negative, I guess. It's going to open downwards, right? So that's one option, but I think I actually like the option where we're just going to put a bunch of different parabolas up here and see what happens. And you too can have fun with parabolas. If you want to get out your graphing tools, go for it, ma'am. Can make some pretty pictures this morning. All right, so we're going to start with the basic graph of y equals x squared. That is a quadratic. We're not worrying about all the other terms. The x squared is really what gives us our parabolic shape, right? You can add some other terms on there if you want to, and we'll talk about what those do. Okay, so what happens if we put a negative in front of our x squared? So instead of +1, we have -1. So we get a reflection across the x-axis when we put a negative sign in, right? And that's pretty standard with the chapter that we did on, or the section that we did on reflections and all that kind of stuff, right? All right, so what happens if we, before I even type it, what happens if I put a larger positive number in front of x squared? So if I do 10x squared, what's my graph going to look like? Steeper. Yeah, that's right, Aiden, right? It's going to, the values are going to, increase at such a greater rate that we're going to get a much, what's the right word? I'm blanking for a minute. Steeper. Now I want to say steeper, Aiden. Much steeper parabola, right? It's basically going to increase at such a greater value. So then shockingly, what happens if I would put a number that's less than 1 in front of here? So let's say, what if I did y equals 1/2 x squared? Anybody? 1/2 x squared is going to give us a parabola that opens up a little more slowly, right? It's going to give us a little bit more gradual of a parabola. And let's say I did a really small fraction, like 1/10. Then our parabola is really just going to kind of meander up there, right? Have you guys seen all this before? Yeah, all right. Cool. That's not what I wanted to do. All right, so let's play a little bit more. Obviously, if I would do like a -1/10 here. Gotcha. You get this nice archway. Can make some rainbows. So now we'll go back to our y equals x squared. Okay. What happens if I add a value outside of my x squared? So what if I add 2? Well, you see what happens, right? But this takes us back. I'm trying to look which section it was. All my sections are running together. I think it was 1/5. Oh, no. Yeah, maybe. 1/4. When we were talking about shifting, reflecting, and stretching, right? When we add a number outside of the function, then the graph shifts upward. When we subtract a number, what do you expect to happen? Yep, absolutely. It's got it. I'm glad that this is working. There's our original function. All right, so then let's talk about what happens when you change inside of our x squared term. So if we add or subtract outside, we're shifting up and down. What would you expect if we add or subtract inside the function? What would you expect to happen? Yes, absolutely. Nope, that's not correct how I wrote that. All right. So remember, when it's inside of the function, it's not quite as intuitive, but at least it's intuitive that it moves. So when we add inside the function, we actually shift to the left horizontally. So usually when you think adding, I think going, up or to the right. All right, so if I gave you a function that's a parabolic function, do you think you could graph it without putting it in your graphing calculator? That's the question to ask yourself. I'm not going to give you a quiz now, but if I gave you, let's see here. Y equals 3x minus 3 squared plus 1. So if you have a little piece of paper somewhere, some scratch paper, see if you think you could figure out where does my vertex start? Where does my parabola shift to just based off of the equation? Aiden's drawing on here. Aiden, do you want to draw on my little graph, my fantastic little graph that I have on here? So the standard form, right, of a parabola, you're welcome to, seriously, Aiden. The standard parabola, the standard, quadratic equation is at 0, 0. All right. What do I know about this parabola, this quadratic equation? I know it's plus 1 outside of my function. So that's going to shift up how many units? Up 1, right? Okay, and what about, there you go, Aiden. Aiden showing us on there. The inside my function, I'm subtracting 3. I have a minus 3. So that's going to give us a horizontal shift of 3 units to the right. So my new vertex of my parabola is right here, right? And then I have one last thing going on, which is that I am multiplying by 3, right? So that is going to stretch my graph. That's the word I was looking for before, stretch and shrink. So this is going to stretch my graph. So and not that I would know exactly what this, looks like, but it's going to stretch it out a little bit here. So it sounds like you guys all kind of all understand kind of what's going on with that. But I thought this would be way easier to look at when we have our graphing tool. It's going to be, oh, thank you, Aiden. You're right. It is going to be steeper. That is a sad looking parabola. Just making sure you guys were paying attention. Right? Yeah, that's a really sad parabola because it should be symmetrical. All right, so if you guys feel comfortable with that, we should be good to go. We'll be able to get through quadratic functions really quickly on Monday. And I have homework sheets for that. But like I said, I just thought, well, since we have a little bit of time, yeah, that's really not a good parabola. I guess really to wrap this up, I should go back to Desmos and officially graph it so that we can actually get a pretty picture here to verify that we are on the right track. That looks much prettier than mine, right? So there's our vertex right there at 3, 1. Nice. There we go. Nice parabola. All right, guys, that's all I have for you today. We're done early. That's a good feeling, right? I know you have your chapter 1 homework to finish up and your chapter 1 test. If you have any questions, let me know. On Monday, we'll start chapter 2, even though we kind of started chapter 2 today. But that way you don't have to look at my sad parabola drawings. At least you got pretty Desmos to look at for some of them. Okay, I'll stay on for a few minutes if anybody has any questions off to the side, but if not, you're free to go and work on anything. If you get stuck on anything or you see anything else on the test that you're like, what did you mean by that? Just shoot me an email and let me know. All right. Thanks for coming today, guys. Have a great day. Have a good weekend. The weather's finally nice. Thanks. Bye, guys. Thank you.